In this video, we're going to look at complementary relationships and symmetry in the unit circle. So if you remember back to your geometry, complementary angles add to 90 degrees, or in our case, working with radians, pi on 2 radians. And so we're going to look at the relationship between the trig ratios, in particular, for the angle theta, which is normally sitting over here, over here, and those for the angles, this one in particular, is the complement. So if you add pi on 2 minus theta and theta, you'll get pi on 2. So this makes these two angles here complementary angles. So what's the relationship between sine, cos and tan for theta and sine, cos and tan for this angle? Let's have a look. So let's start in this first quadrant and look at the trig values for this angle here. So if we pull this triangle out over here, hypotenuse is 1, let's label this side as A, this side as B. To find cos of theta is adjacent over hypotenuse, so cos of theta is A over 1, which is just A. Sine of theta is opposite over hypotenuse, so sine of theta is B. And tan of theta is the opposite side over the adjacent side. So normally for points on our unit circle, we label the point by its coordinate points, which are A and B. And we know that this A is cos of theta, or cos of our angle, and this B is sine of theta. So now let's have a look at the complementary angle. And you can see that I have flipped and rotated our right angle triangle so that it's sitting coming from pi on 2. And so what we're interested in is what are the sine and the cosine values for this angle here, so for this point here on the unit circle, and that angle there is in fact pi on 2 minus theta. So now we want to figure out corresponding sides for our triangle. So if we go back to our original triangle at the top, and I'm going to colour in the adjacent side purple. It's not a very good colour here. But on that triangle there, that's the purple side. And then over in our first quadrant, that's the purple side there. And that side length is A, which means that on our axis, that will be the value of A. And then if we do the same thing on our original triangle with our B side, which I'm colouring pink, and then that makes this side here B as well, which means that that side length there is in fact B. And so if we read down onto our x-axis, that value there will be the B value. And so the coordinates for this point are our x value for this point is B, and our y coordinate for this particular point is A. We also know that the x coordinate for a point and that our y coordinate is the sine value for that point on the unit circle. So let's summarise what we've got. So our first relationship is that cos of pi on 2 minus theta is equal to B. Cos of pi on 2 minus theta is equal to B. And B is equal to sine theta. So B is equal to sine theta. We also have the relationship that sine of pi on 2 minus theta is A. And we know that A is cos of theta. So that means that sine of pi on 2 minus theta, which is equal to A, is in fact also equal to cos of theta. So let's pull this all together. So you'll notice that these two angles are complementary angles. If you add them together, you get 90. And you'll also notice that's the same for these two angles. The other thing you might notice that if you start with cos of one angle, it becomes sine of its complement. And if you start with sine of one angle, it becomes cos of its complement. What happens with tan? Okay, so let's go. Tan of theta is equal to b over a. We have that up here. And tan of pi on 2 minus theta is in fact sine of pi on 2 minus theta over cos of pi on 2 minus theta. And we said that sine of pi on 2 minus theta is equal to a, and cos of pi on 2 minus theta is equal to b. And so we have that tan of pi on 2 minus theta is equal to a over b. And that is the reciprocal of the original tan value. So the original tan value was b over a, and tan of the complementary angle is a over b. They're flipped. What about angles in the other quadrants? So here we have an angle in the second quadrant that is sitting up against pi on 2. So the actual angle that we're going to be working with this time, starting from the positive x-axis and coming all the way around to there, is in fact pi on 2 plus theta. And so again, we want to get our coordinates for this point, for the angle pi on 2 plus theta. And so I'm going to colour code the little triangle at the top and the triangle in the second quadrant so that we can see which side matches which. Okay, so this line here is the same size as this line here, and so it has length b, which means that the x coordinate for this point is going to be negative b. So negative b goes in here. And this side here, the purple side, is length a, which means that this length here is a. So the y coordinate for that particular point, where it cuts, where it's level with the y-axis across here, that value is going to be a. And so again, this is our cos value for our point. And this is our sine value for our point. So let's summarise them down here again. So we have cos of pi on 2 plus theta is equal to minus b. And it's negative because we're working in the second quadrant, and you expect cos to be negative in that second quadrant. So we're going to have a negative answer. Now the b, we know, is equal to sine of theta, and so we will get cos of pi on 2 plus theta equal to negative sine of theta. And sine of pi on 2 plus theta will be a positive value because sine in the second quadrant is positive. It's equal to a, and you can see here at the point up here that it's equal to a, so positive sine value, which means it's equal to, we know that a is equal to cos of theta. And so the trig ratio for the quadrant that you're working in will determine whether your answer is positive or negative. And so in the second quadrant, cos is negative, and in the second quadrant, sine is positive. Let's have a quick look at tan. So tan of pi on 2 plus theta is equal to sine of pi on 2 plus theta over cos of pi on 2 plus theta. Our sine of pi on 2 plus theta is a, and our cos of pi on 2 plus theta is minus b. So again, we've got this reciprocal relationship between tan of the complementary angle, well, it's not really complementary, and tan of the original function. And we've also got a negative value here for tan, and in the second quadrant, you expect that tan will be negative. So now we're going to work in the third quadrant, and I've gone ahead and I've put in our angle of 3 pi on 2 minus theta, and put the triangle in and coloured it up, and found that the x-coordinate of this point here is minus b, that pink line, minus b, and the y-coordinate is minus a. And remembering our x-coordinate gives us our cos value for that angle, and our y-coordinate gives us our sine value for that angle. So let's have a look at our relationships. And here they are here. So cos of our angle, working in the third quadrant, so the only thing that's positive in the third quadrant is tan, and here's our angle. So cos of this angle is going to be negative sine of theta. And sine of our angle is going to also be negative cos of our angle. And for tan of our angle, when we go through and substitute sine over cos, we get minus a over minus b, which becomes positive. And our answer, again, a over b, is still the reciprocal of tan for the original angle. Let's look at the last quadrant. Okay, so finally, let's look at the fourth quadrant. Again, I've coloured the sides and the corresponding sides here for our angle of 3 pi on 2 plus theta. And the coordinates of this point now are our x value, that side length is b, so our x value is b. So cos of 3 pi on 2 plus theta is equal to b. And our y value is this distance here, which is the length of a, but we're down in the negative area, so it's minus a. So sine of 3 pi on 2 plus theta is equal to negative a. So we're working in the third quadrant, and so the only value that we expect to be positive in here is our cos value. And you can see our cos value here is a positive number. So we're working with our angle in the third quadrant, so the only trig ratio that we're expecting to be positive will be cos of that angle. So cos of that angle we're expecting to be positive, and because it's cos, the matching value will be sine, and it's sine of theta, and it's positive. So sine of the angle that in the fourth quadrant is going to be a negative number, because only cos is positive in the fourth quadrant, and so we have negative cos of theta. And our tan value should also be negative, because this is the third quadrant. When we substitute in our values, we get a negative value, and again, it's the reciprocal of tan of theta. So as you probably picked up now, there are some patterns with these relationships. If you're finding cos of some particular angle in a different quadrant, then the equivalent angle is sine for that particular angle that you're adding or subtracting. So you can see plus or minus theta ends up with a theta here. That's exactly the same. And whether you end up with a positive or negative answer is determined by which quadrant this angle is in. Okay, so whichever quadrant this angle is in, what you want to know is, does this trig ratio for this quadrant give you a positive or a negative value? Now you'll notice I've used an n here and said that that's an odd number. So these are multiples of pi on 2. So these are the values that you'll get for angles on the x-axis, the positive x-axis and the negative x-axis. Our other pattern for tan is very similar. If you're finding tan of an angle that's not in the first quadrant, it's equal to the reciprocal of tan for whatever you've added or subtracted to the pi on 2 multiple. And it'll be plus and minus determined by which quadrant this is in. Let's have a go at some questions. So press pause and have a go at these, and then I'll put the answers up for you in a second. So how did you go? Cos for quadrant 1 is positive. Because we're finding cos, our answer will be sine, and our angle we're using is theta. So positive sine of theta. For this one, hopefully you made sense of this little angle over here, which is increasing as we go pi on 2, 2 pi on 2, 3 pi on 2, 4 pi on 2. So this, when we've come all the way around, is 5 pi on 2 plus theta, which puts us in quadrant 2. And sine in quadrant 2 is positive. Because we're finding sine, our answer is going to have a cos and our angle is theta, so the answer is positive cos of theta. This third one's a little bit more difficult, but the same process. Pi on 2 plus theta is in quadrant 2, and so in quadrant 2, tan is negative in quadrant 2, so that's the negative sign here, and the answer, the value is 1 over tan of theta. Now tan of theta, we're told in the question up here, is 0.5, so put 0.5 down here. And then I simplified this. 1 divided by 0.5 is the same as 1 divided by 2. When you divide by a fraction, change the divide to multiply and flip the fraction, and you get an answer of 2. And of course we had a negative.